Hi, I'm Steve Paradis. In CAD lighting, the umbra of a spotlight is that brightest part of the spot, where the light is not obstructed at all by the spotlight enclosure. In the penumbra, the light gradually fades from full to nil at the outer edge of the penumbra, or at least it would be completely dark if there were no other lights in the scene. This is a schematic drawing of a spotlight cutaway to show the light and the aperture and the geometry. If one were an observer within the umbra, looking back at the light, one would have an unobstructed view of the entire light. But in the penumbra, it turns out, if you study the geometry, part of the light is obstructed by the front of the aperture. And at the outer edge of the penumbra, the light is fully obscured. Now we can demonstrate that with the use of camera objects in TurboCAD. It turns out these two are going to interfere with our view, and so I've got them on their own penumbra layer, and I'm going to make them invisible so that they don't mess us up. And we don't need rendering for this, and we do need a world plane view to place three camera objects, one in the umbra, another one in the penumbra, and a third outside the penumbra altogether. And I'll do the first one and go away and come back. So here's camera by 2 points, and we'll place that camera somewhere in the umbra here, and then we'll aim it right at the center of the light. And so there's the first one, and I'll be right back. Okay, so now we have camera 1 in the umbra, camera 2 in the penumbra, camera 3 outside the penumbra. All three of them are shown in the design director, and it's quite convenient to attach them, which means a separate window will be created for each camera showing the view of that camera, and then we'll have a look at those. So we'll attach 1, 2, 3, and then we can tile the windows, and we can have a look at each one. Let's take a look at one and let's render that, and zoom selection. I'm going to do these for all three, and then I'll come back again. So after rendering and then zooming to the selection, we see that in camera 1, which is here, we have a completely unobstructed, uneclipsed view of the light from within the umbra. Now over here in camera 2, about half of the light has been obscured in the penumbra. And in camera 3, none of the light would be seen. You wouldn't see it if you had the full 360 degrees of can. Now I'd like to hold on, we're going to stop again. So a few more things about this drawing. It's been made with numerous constraints. For example, these light rays that define the penumbra and umbra are constrained to be tangent to the sphere and also coincident to the knife edge of the aperture. And there are 3 spins, this penumbra, the sphere itself, and the aperture, and they're spun from 2D profiles that are constrained and that are compound profiles, so that when they're updated, the 3D spins made from them are updated as well. And I can demonstrate that because there are 3 constrained dimensions. 1, the size of the aperture, 2, the recession of the sphere within the can, and 3, the diameter of the sphere itself. And those can be changed in the calculator palette their percentage numbers. So for example, the recession, this is 75%. If I change that to 50, everything is immediately updated, including the angular dimensions, the sizes. Let's put this back to 80%, and perhaps maybe making the aperture a little bigger. Instead of 35, we can make it 55. I've got problems with overlapping dimensions, but you get the idea. Everything is immediately updated. How about the sphere smaller? 5. Fun with TurboCAD.